The idea was just as the oil was sprayed, it would pick up some charge, just like the water droplets would. And actually a side benefit of using the oil, it was quite pretty. Fletcher talked about how when he first saw it, it looked like a bunch of miniature stars glowing in his apparatus there. So, if the charge is only carried by an electron, then when the charge on the oil drop was measured, it would have to be some multiple of the electron charge. You just had to find the common denominator of the charge measured on all the drops, and then the smallest one you could extend out a graph, and that would be the charge on the electron. Harvey adjusted the electric field, right here. Your electric field was several thousand volts, and he adjusted it so that these oil drops fell with a constant velocity. He estimated the size of the drop, and again, he's looking at it with a microscope. Here, this is a simulation of Harvey's eye. He would get the size of the drop, and then he could figure his mass because he knew the density of the oil. So now the electric field was known because it was set, and the mass of the drop was found because it was calculated from its size and also by the density of the oil. Once these data were all collected, Harvey calculated the charge on the oil drop. He did it for a large number of drops using the below approach. We've got the electric field going up, delivering a force up, the gravity pulling it down. So we have the electric force minus mg equals 0. And we have, this is the charge now on the individual oil drops, and it's mg divided by E. And we know all these quantities. So many hours were spent by Harvey staring into the microscope watching the sparkling oil drops. What's missing in this calculation is the real-world correction. You also have a viscosity of the oil drops, and that will provide an upward frictional force. And that's going to be up like that. And using the Navier-Stokes equation, and we certainly don't need to know that in high school just yet, that would calculate what the frictional force was, that was added, and then all the data were graphed, and this was laboriously performed without the help of computers. They didn't exist then. And you now had a graph, and that would actually give you the charge on the electron. The experiment was repeated again and again with increasing accuracy by many other groups, and the accepted value of the elementary charge, or the charge on the electron, is 1.602177 times 10 to the minus 19th coulombs. And for those of you who will be taking physics in college, this is a pretty standard experiment to be done. And it is very laborious and very time-consuming, and staring into the microscope for long amounts of time. Here, maybe someday this will be your eye over here looking through a microscope. It takes a lot of time, but you do get the result after you do all the work, and you'll find out the electric charge. Here's a picture of the experimental setup that was used by Robert Millikan and Harvey Fletcher to determine the charge on the electron. And it's a little tricky to see, but if you just look right here, that's a lab bench. The entire setup fit on one lab bench, and that's how they came up with the charge on the electron.